So our unit has been radical functions. So today we're going to be graphing them, which it should be pretty easy of a lesson for us because we should be pretty good at graphing and taking our knowledge of graphing other things and be able to apply it here. So square root function, the parent function, which means non-shifted function, looks like this for the square root. So f of x is equal to the square root of x. So that's going to look like this. Does everybody see? Which, let's see why this makes sense, okay? Let's see why the graph makes sense. Don't we know there's not going to be anything negative underneath here? So do you see how that would exclude all of these values behind here? So that's why it's only from here over. And then notice if we plug in 0, what do we get? We plug in 0. What's the square root of 0, guys? 0. So do you see how we're at 0, 0? If I plug in 1, what will I get? Square root of 1 is 1. So this is over 1 of 1. And then if I plug in 4, what do I get? 2. So over 4 of 2. So these are just some points on the parent function. Does everybody see it? And then this is what a cube root function looks like. So we have f of x is equal to the cube root of x. Non-shifted function, cube root of x. Notice it kind of looks similar to a square root function, but it curves down like this, kind of like a snake, I call it, like an S. That's what a cube root function looks like. And notice, remember, it's okay to have negative odd roots. So our x values, our negative x values are graphed. Does everybody understand? So think of some x, y points on the parent function of this. We plug in 0, what we get? 0. Cube root of 0, 0. If I plug in 1, what's the cube root of 1? 1. So that's 0.11. And if I do the cube root of negative 1, don't I get negative 1? Negative 1. So these are just some points on the parent function. Now, the next point that would come out evenly would be what value of x? That would come out like a pretty answer. 8. Good, Keelan. 8, right? Isn't that 2? And then negative 8 would be negative 2. So see how the graph makes sense here. So we know that shifting for all function works the same. So shift from the parent function for all functions works the same. Just a reminder here. So this is just for functions in general. The a multiplied in front of the function is a stretch or compression. If a is greater than 1, then it's a vertical stretch. It's going to be a greater acceleration. If a is less than 1, it's a compression because the acceleration is less. And then anything added and grouped in with x is your shift left and right. We always go opposite of the sign. And then anything added to your function on the outside is your shift up and down. The sign will stay the same. And then just remember the negative in front of a has nothing to do with stretch or compression. That will be a reflection over the x-axis. So now that we know how shifting works, we can graph these functions from the parent function. What's the what? The function. So graphing for all functions works the same. Is everybody good? Do we need this up for another second? But just a reminder, we've already learned this because we know that shifting for all functions works the same, so this is not new to us at all. We know how shifting of all functions works the same. Here we go. So let's do just some examples here. Get out your little, we can graph these on your little graphy whiteboard thing. So first of all, it says graph, then we're going to state domain and the range. So first of all, you say, I see that this is a square root function. It's a shifted square root function from the parent function. So we would look underneath the house here. That's my shift left and right. It goes opposite. So we're going to be going from the origin left 3. Does everybody understand? And we'll be going down 2. Yes. No. Y-intercept is when x equals 0, right? So if we plug in 0 and calculate it, that'd be where it crosses the y-axis. So the parent function of this is the square root of x, right? So we're just taking that parent function, shifting it left 3, down 2. So it used to be like this, you guys. I'm going to just draw it in once again. This would have been the parent function. We're now taking that. We didn't do any stretch or compression. We're going to go left 3. So that's starting at the origin. We're going left 3 and then down 2. Down 1, 2. So then we could plot more points here. This was over 1 up 1, right? Or we could put it in to actually calculate it. So this will be like this over 1 up 1. And then notice this was up 1 over 1, 2, 3. So up 1 over 1, 2, 3. And we just have this shifted square root function here. Now let's see why this domain makes sense, because because we have been looking at stuff like this all along. If I said to you without the graph, I said, what's the domain of this? You'd say this has got to be x plus 3 needs to be greater than or equal to 0, correct?
Yeah.
Subtract 3. So x will be greater than or equal to negative 3, which doesn't that make sense? Look at our domain. You see how it's negative 3 to positive infinity. So it's all making sense, hopefully. Is everybody good? So our domain, let's do it in interval notation. It's negative 3 to positive infinity. And we know that it includes negative 3, so bracket and positive infinity. Once again, because it's okay for that to be 0, it includes negative 3. Now our range is our y values, the lowest y value to the highest y value. So lowest y value is negative 2, and isn't it going upwards to positive infinity? Yep, negative 2 to positive infinity. Pretty easy, right? Why don't I do an 8 like this? Oh, I don't know, that's hard. Yeah. Yeah, what's it to you? Yeah. Okay, here we go. So I want you in words to describe the shift here. So what's my shift left and right? This is important. In words, describe the shift. No shift left and right. Yep. There's a shift of 5. Reflection over x. Okay, here we go. Let's graph it. So you would say, okay, sweet, here we go. Once again, the original function looks like this, over 4 up. 2. So this was the original, and now I'm going to graph the other one. So we're going up 5, so up 1, 2, 3, 4, 5, and now it's a reflection over the x-axis. So won't that be flipping down like this? Taking that, reflecting it, won't it be like this? Over the x-axis. So we'll be going down 1 over 1, because this was up 1 over 1. Then down 1, now that was up 1 over 1, 2, 3, so we're going down 1 over 1, 2, 3. Now we could literally plug in those points, you know what I mean, plug in points. I'm just recognizing some key features here to make my life easier. So this is what our function looks like. Does everybody see this? Now, interestingly enough, okay, so let's do domain and range while we're at it real quick. Okay, so domain. Yeah. It's still a shift of up 5, always, right? Okay, domain. What's my domain? 0 to infinity, which makes sense. Look, don't we know x has to be greater than or equal to 0? So that's why our domain is 0 to infinity. And then our range is lowest y value to the highest y value. Isn't it going downwards? So negative infinity up to, negative infinity up to 5. Does everybody see it? Do we have questions? Okay. Okay. So let's go ahead and do a few. I don't need to do this one, or do I? You're good? Okay. Okay, awesome. We'll do this and then you'll be able to finish the ones on the worksheet before lunch. We'll fly through this. Here we go. In words, describe the shift. Left 3. Then no shift up and down. What's that called? A stretch of 2. That's how we'd write this out. So our original function, I'm going to just draw it in for kicks and giggles for the first little bit. So it looks like this originally. Now we've shifted that. Left 3, so right back here's our starting point now, right? But now we have a stretch of 2. So wasn't the acceleration or on the parent function a 1? So now we're going to be stretching this up. The acceleration is going to be getting larger, quicker, correct, everybody? A vertical stretch. So let's think about this. We could do this a couple different ways. First of all, we could just plot points. Let's plug in negative 2. Everybody, here we go. 2 times the square root of negative 2 plus 3. That's 2 times the square root of 1, which is 2. So instead of going up 1 over 1, we're going up 2 over 1. Negative 2 up 2 makes sense, right? You see it? Yeah. Okay?
So if there's a 1, then you go over 2.
Nope. You go up a half over 1. Because it's a compression. Oh, you were saying, no, you said up 2 over. But it's not a slope. It's an acceleration. Yes.
So when you plug in
Not slope, acceleration though. Yeah, well, let's keep drawing the graph. So let's plug in another point. I mean, guys, what's another point that's going to come out pretty here? What does this need to be to come out pretty? Think advancedly. 4. So what x value am I going to be plugging in? So my next pretty x value will be 1. Does everybody understand why I chose to plug in 1? So we have 2 times the square root of 1 plus 3, which is 2 times the square root of 4, which is 2 times 2, which is 4. So we have a point 1 comma 4. So over 1 up 1, 2, 3, 4. So do you see how the acceleration's getting larger quicker? Yeah, probably. So then from there, let's do domain and range. So domain. What's my domain? Which makes sense, right? X has got to be greater than or equal to negative 3. So negative 3 to infinity. And my range is 0 to infinity. I'm not going to, range 0 to infinity. Everybody good? Ready to practice?
Yeah.
I don't care that much if you plug it in your calculator. However, hopefully you could do it by hand when your calculus teacher will not even let you pick up a calculator, which is going to happen. I did calculus 1, 2, and 3 without even so much as looking at a calculator. So I'm just saying, it's fine that you're using your calculator, but hopefully you guys understand how functions work and you could do it by hand, okay? All right, do 1 through 10, and you can just grab them on your little, yeah. So what I want you to do is in words describe the shift on your paper, and then just graph it on there, and then check it with me, and then you can move on. We're going to do some cube root functions. These are the snake-looking ones. So remember the parent function for these, we had some points. I'm going to list some out just to remind us. 0, when we plug in 0 into the parent function of the cube root of x, we get 0, correct? Okay, 0, 0, and then we have plug in 1, you get 1, plug in negative 1, you get negative 1, and so on. You plug in negative 8, you get 2. If you negative 2, if you plug in 8, you get 2. So that would be the parent function. So now we're taking, so I'm going to graph that this time. Okay, here's our parent function. So now we're taking that and shifting it up 3, correct? So we're going up 1, 2, 3. So there's our origin, and so we'll still be up 1 over 1. Notice that's up 1 over 1, down 1 over 1. And then from there we went up 1 over 1, 2, 3, 4, 5, 6, 7. 1 over 7. And then domain and range. Isn't domain negative infinity to positive infinity? And isn't range also that? Okay. Okay, so let's do this one. So inwards, let's describe the shift. So we would be going left 1, down 3, stretch of 2, and then reflection over x. So I'm going to start out by where my origin would be, my new origin. We're going left 1, so negative 1, down 3. And then from there, we're going to be reflecting over the x-axis. So instead of going up and over this way, we're going to be going down and over, right? I would take that down and then up and over this. So let's see, sorry. So I'd be down and then up and over this way. Okay, and we have a stretch of 2. So we can do this a couple different ways. You can plug in some points or look at the relationship between what we originally had in the cube root of x. So give me some points, maybe. When you're at 7, you get negative 7. That's clear down there. Okay. Is there another whole number point? We'd probably be done if you guys were actually helping me out over there.
Oh, yeah.
Plug calculator or calculate it by hand.
Whoa, why didn't you say over there?
I was referring to you guys.
Sitting there.
Well, I was looking directly at you guys.
Yeah, but you said over there.
You plug in -2, you get -1. Okay, perfect. And then if you plug in 0, we will get -5. Something like this. Is everybody good with that? Yes. That point, that wasn't very good. This was a little bit more accurate because we kids coming down to -7. So do you see how it's stretched out though, everybody? And then it's reflected. Okay, so we're good. We're to do 11 through 13. So basically you can finish the front page. Are we good to move on? So flip to the back page. So this is really where we get to the important stuff, and here's why. Looking at this, notice right now when we look at this, you can't determine the shift from the parent function. Here's why. True shifts from a parent function will just have an x, nothing in front of x. Does everybody understand? So you've got to look at this and say, can I rewrite this in a better way? So can anyone think of how we might do this?
25.
Yes. Perfect. Well, so okay, so you just said over there, you guys are saying that there's a 25 in common here? Is that what you guys are saying back there? So let's factor out a 25. Now we want to factor out by that leading number so that that x will be +1. So when we factor out a 25, don't forget when you factored it out, you've got to write what's left over in each term. Divide by 25, divide by 25. So left will be x minus 4. And then we still have our -1. Now remember, isn't it true that multiplication of square roots we can have split apart and multiply them together? Like if you have the square root of 25, can you multiply to the square root of 100 minus 4 and put it under the same root? Yes. So can we split them apart now?
Yes.
So let's do this. Technically we have the square root of 25 times the square root of x minus 4 minus 1. So we have y is equal to 5 square roots of x minus 4 minus 1. So now we don't need to graph it. We could, if on the homework it says graph it. I know you know how to graph. You just did it. So just describe to me what this graph would look like. Basically, I want you to describe the shifts and then describe the domain and range just based on the equation here. So we would say right 4, down 1, and then a stretch of 5. So then we would say our domain is what? From this, greater than or equal to 4, guys, right?
Yeah.
4 to positive infinity. Does everybody see why?
Yes.
So 4 to infinity, including 4, and our range will be -1, and it's growing upwards, right? It wasn't reflected, so growing up to positive infinity. Okay. So what about this one? Let's look at this one. Otherwise you'll all probably ask me. So looking at this, once again, it's a cubic, and I'd say I probably could write this as a shift from a parent function. But that 8 is a problem, so let's fix that. Let's factor out at 8, correct?
Yeah.
So pull out 8, so then you have to divide each term by 8. So what's left? X minus 1/4. Okay, perfect. So now we have y is equal to negative cube root of 8 times cube root of x minus 1/4. And so we have y is equal to -2 cube roots of x minus 1/4. So we'd say right 1/4, stretch of 2, reflection over the x-axis. So our domain is going to be 1/4 to infinity, correct?
Yes.
And then our range is going to be negative infinity up to what? Was there any shift up and down? So it would be 0, correct? Okay. Okay, what about this one? This one's trickier, and this is the one that I got out of the pre-calc book. So let's see here. This is how we would do this one. So technically, don't we have the square root of x minus 4 over the square root of 4, which is really, oh, and then we have our minus 2, sorry. So we really have y is equal to the square root of x minus 4 over 2 minus 2. So that's technically y is equal to, can't we pull that out? That's 1/2 times the square root of x minus 4 minus 2. And then you guys are good with domain and range. So do you see how I did that? Pretty simple. Okay, that's really it. So don't let it throw you off if the 10's back here. That's still 10 added, correct? Okay, I won't waste your time then and go through this. So on the online homework, there's not any on the worksheet like this, but there is some on the online homework. If I said to you graph this function, would you know what you're doing? What would you do? So where are you going with this? You're right, but what are you trying to do? Yes. Good. You're trying to get in y equals, we graph things in y equals form, Bailey, you're right. So we got to solve for y. So we'd add 3. So right now we have 2y squared equals x plus 4. Then what would we do next? Divide by 2. So we have y squared is equal to that. Sorry. I didn't want to have to erase, so I'm cheating. That's the same thing, right? Divide that by 2, divide that by 2. Square root of both sides. I just did that because I didn't want to erase. I could write it all over one though. So then we'll square root both sides. So then we would graph this. Does that make sense, everybody? Just get it in y equals form is what I'm getting at with this problem. Okay, so just finish the worksheet for some practice on there. Those are really good story problems. Just seeing if you know how to plug things in. It's pretty simple. So do those ones, and then that is everything for today.